Hello, today I would like to begin with couple strong geomagnetic storms which took place during last week and which were unnoticed by NOAA. Let's start with the latest aurora outburst which took place in the morning of November 5th. As you can see, there were two events during which the auroral power reached more than 100 gigawatts, what is a sign of strong geomagnetic activity. First outburst took place exactly at 6 UTC, and second one at 7:41 UTC. In Europe, ground magnetometers noticed only some minor disturbances at this time. However, in Canada, geomagnetic field was affected much stronger, and in some stations the jolt reached 400 nanoteslas. One of GOES satellites managed to record the disturbances of satellite environment at the same time when auroras appeared on the skies. But it seems that the strength of auroras and geomagnetic pulses is no longer a factor which defines the planetary K index, which was increased only to 3 by SWPC specialists. However, they managed to notice previous geomagnetic instabilities which took place some 6 hours earlier, and which were recorded only in Europe, while in Canada they caused only some tiny disturbances. However, in Kiruna, local K index reached 6 points as the geomagnetic pulse reached more than 400 nanoteslas. Yet, I couldn't find any signs of auroras on their all-sky camera archive. Maybe because of brightness of the moon. Another interesting event took place 3 days earlier, on December 2. Again, there were two outbursts of auroras. First, stronger one was recorded by POES satellite at 3:50 UTC. Auroral power reached enormous value of 153 gigawatts. Second impulse, which was recorded just before 14 UTC, was weaker. Auroral power reached 117 gigawatts, what is still well above average. But this time things are getting pretty odd. During both events, ground magnetometers didn't record anything what could explain such strong auroras. As in Europe, so in Canada. This is why in this case I can forgive NOAA the lack of any response of KP index during the entire day. But let's look now on the solar wind readings from both days to see if we can point out some possible cause of those geomagnetic instabilities. Those who watch my movies for some time won't be probably surprised if I tell that as on December 2nd, so on 5th, ACE satellite didn't record anything what could be the cause of auroras and geomagnetic pulses. During the first geomagnetic storm of 2nd December, BX magnetic component was the strongest one. BZ, which is supposed to be responsible for geomagnetic instabilities, was at this time oscillating around 0. Similar situation can be seen at the time of second auroral outburst on the same day, only this time BX was pointing in the opposite direction. During the first disturbance on December 5th, IMF was more unstable, but still there is nothing on this chart what would give any hint as for the possible cause. Second event took place soon after a stronger shift in magnetic orientation of IMF. But again, BX seems to be affected mostly, as it moved from -6 to 6 nanoteslas. But according to current space weather models, it shouldn't trigger a geomagnetic storm. Okay, let's move to another subject. Disturbances of electric potential in the ionosphere. I will show you 3 images from December 3rd. On the first one, we can see that some part of the positive potential moved to lower latitudes. However, the main differential is still placed over the northern pole. Notice as well that negative potential is much stronger, around minus 14 kV. Positive one shows only 6 kV. On the second image, most of the positive potential returned to the right position, but still a small part of it can be seen over the equator. Negative value gained strength and started to show minus 30 kV. But this is the image which freaked me out. As you can see here, the entire positive potential disappeared from the polar cap and moved to lower latitudes. And what is even more important, it became stronger than the negative charge, 15 to minus 5 kV. Good that this situation was only temporal, and now when I record this movie, the differential seems to be in perfect condition. Another good information. Atomic oxygen returned to its natural condition and the biggest concentration is again placed on the day side of our planet. I'll make you even more relaxed when I tell you that even the density of ionospheric electrons is visibly lower than before. Yet, their behavior is still far from common. Anyway, I think that I've managed to find another connection. It seems that the behavior of atomic oxygen might depend on the magnetic orientation of the interplanetary magnetic field, or IMF. According to all models, Earth-facing disk of the Sun is currently dominated by negative polarity. Black field lines are pointing directly at our planet. However, ACE readings do not agree with the simulations. Even if the T angle of IMF is lately pretty unstable, we can see that it started to show rather 180 degrees than 360. What means that we entered part of the heliosphere with outward positive current flow. Of course, it can be just a coincidence, but it is the second time when atomic oxygen changed its behavior during the change of IMF orientation. It seems that when Earth stays in negative part, atomic oxygen is freaking out, while it calms down when the orientation is positive. It's just my guess, but this can be connected with another process which is still bothering me: discharge of current rings. A perfect example of such discharge took place on December 5th. When we look closer, we will notice that there were actually two discharges, which took place one after another. From 4:30 to 6:30, and from 6:30 to 8:30. I've checked different readings and it seems that the main suspect is BX component, black line. It is the only factor which went through some more significant changes at the time of discharges. Notice as well that after the discharge, the angle of equatorial magnetic connection changed. I was talking about it 2 movies ago. This is interesting. After the first reset, The initial connection took place in different parts of the globe. Before I will move to the main subject of this movie, I would like to show you a nice example of electromagnetic forces which affect the atmospheric currents. Of course, you might say that it is just a front line separating different air masses, but for me it is simply a magnetic field line. You shouldn't have problems to see opposite polarities, but most important is the fact that this air mass is moving against all known air currents of Earth. Besides, there is one big problem. Right in the middle of this air mass, pressure is extremely high. It is reaching 1042 hectopascals. And yet, clouds are spinning there counterclockwise, what is against the rules of meteorology. But let's move to the main topic: patterns and frequencies of geomagnetic instabilities. In previous episode I was talking about events which are taking place every day and which are connected with tilts of our main magnetic axis. Today I would like to show you how it is connected with the daily geomagnetic jolts, which disturb the field greatly, but only on local scale. However, first I need to speak about the components which describe magnetic fields in 3 dimensions. What shouldn't be hard to understand, as we are using the same directions which are being used in mathematics to describe 3D environment: X, Y, Z. In the case of magnetic fields, they are called Bx, By and Bz. If you have some knowledge about space weather interactions, you know probably that in all official models Bz component is the most important one, as it is responsible for geomagnetic activity during different events. When Bz is directed southward, negative values, magnetic reconnection is taking place and particles enter the ionosphere via polar cusps and cause auroras. Maybe couple years ago this model was absolutely correct, but today it doesn't work almost at all. Because the polar cusps are now located in different parts of magnetosphere, what I was explaining last time, geomagnetic field started to be affected by different magnetic components. For example, cusp, which has its opening in the front of bow shock, makes the planet vulnerable to Bx component. While the cusps which appear on sides of magnetosphere allow solar particles to enter the ionosphere when By is the dominating component of the IMF. But because there are 2 cusps which are connected with the By component, geomagnetic response will be different depending on the east-west magnetic orientation. Particles are capable to penetrate the magnetosphere only from one side. For example, if By is pointing to the west, according to Earth rotation, particles will enter through the eastern cusp, while the second opening won't be affected. I can be wrong, but I think that such situation took place between 2 and 3 UTC on November 24. These pulses reached around 400 nanoteslas in some Canadian ground stations, while in other regions it wasn't noticed at all. And here we can see clearly that field lines which create one of two northern polar cusps were at this time connected right in the affected area. I would be absolutely delighted if all of those pulses would be so easy to explain. But of course, life is brutal. It seems that the magnetosphere simulation won't work in the case of jolts which were recorded in Europe. They take place mostly in the night hours. And this part is not capable to generate field lines which create the magnetotail. But I have still couple options. First, there is the data recorded by different satellites, and second, I can always request another SWMF plus RCM model run. But not in this episode. For today it is enough. Class dismissed. Be safe. Peace.